Okay. Start.
Good afternoon or good evening, as the case may be. So today we are going to talk about binomial theorem. What is binomial theorem? Binomial theorem simply means it's just expansion. All what we'll be doing in this course is just expanding and expanding and expanding. So let's look at this. We have x plus y all raised to power 2. Why I'm redoing it again is that because I noticed that on the Zoom class, majority of you guys can't hear what I was saying. So that is why I'm redoing the class again. So we have x plus y all raised to power 2. We all know this: x plus y, x into bracket x plus y into bracket x plus y. So when you expand everything and do the right thing, you will get x squared plus 2xy plus y squared. So same thing applies to x plus y raised to power 3. When you do it, it becomes stressful when the power keeps on increasing. Fine, x plus y raised to power 3 is easier to expand normally. When you have x plus y raised to power 10, will you now start? No, it's wrong. So that is why we need to know what is called binomial theorem. So majority will be wondering that how did I know that x plus y raised to power 3 will give me all this without even trying to solve it as I solved the first one? Don't worry, it's not hard. There is a trick to this binomial theorem. If you look at the first one, you will notice that the power of a letter before the sign keeps on reducing, while the next one keeps on increasing. What do I mean? Let's take this as a case study. X plus y raised to power 2. The power here is 2. So x is raised to power 2. So the power of x keeps on reducing by 1. So x squared, this is x. Then the next one keeps on increasing. This is y. Here, the power of y here is 0. So the next one is 1 and this one is 2. So it also applies here. X raised to power 3. If you look, the power of x reduced by 1, x raised to power 2. This one is increasing. The power of y keeps on increasing. Y raised to power 1, y raised to power 2, y raised to power 3. You now be wondering, how did I not get 3? Or how did I get 2? But look, fine, you can know how to get 2 when you expand. But this, I did not do any expansion. But how did I know that 3 is meant to be here? So that is what is going to bring us to the next subtopic, which is method of solving binomial theorem. We have two methods of solving binomial theorem. We have the Pascal triangle and we have the combination method. So what is the Pascal triangle? Pascal triangle is just a way of writing the coefficient in a triangular form. If you look at what I wrote here, it's a triangle. So representation of all these numbers inside here is called Pascal triangle. So how does Pascal triangle works? We have 1. There is nothing before 1. Nothing plus 1 is 1. There is nothing after 1. 1 plus nothing is 1. So if you use that same idea, you will notice that you will start with 1 and end with 1. So I will stop using that there is nothing before 1 and there is nothing after 1. So I will just start with the numbers after 1. This is what I mean. Look at this. There's nothing before 1. Nothing plus 1 is still 1. And there's nothing after 1. 1 plus nothing is still 1. So I won't do that. I'll just know that if you start with 1 and end with 1. So 1 plus 1 is 2. Since there's nothing, just put 1 and put 1 here. So you start with 1 again and end with 1. So 1 plus 2 is 3. 2 plus 1 is 3. Then end with 1. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And you end with 1. First, binomial theorem is always in the form a plus b all raised to power n. Binomial theorem is always in the form a plus b all raised to power n. So if the power of n, where n is called the power, we all know that. So if the power of n here is 0, so it will be a plus b all raised to power 0. Then you will use this. If the power is 1, you will use this. If the power is 2, you will use this. If the power is 3, you will use this. And if the power is 4, you will use this. So, what is now the application? For the first one, we did x plus y raised to power 2. What is you can relate it to this. Why? Because the power here is 2 and the power here is 2. The difference is just that this one is A, this one is B, this one is X and this one is Y. So you can still solve it using this. So how will you now solve it? We know that in Pascal triangle, or what I taught you earlier, that's what we are going to use.